Okay, let's see some other things we can do with radicals, such as combining. If I have 2 square roots of 3 minus 4 square roots of 3. This is kind of like saying 2x minus 4x, which would be negative 2x. When these are the same, these are called like terms. So you simply do 2 minus 4, negative 2, and then you keep that root the same. So it works the same way. I mean, if you had something like 8 square roots of 3 plus 5 square roots of 3, that would just simply be 13 square roots of 3. Now, if you had something else in here, like let's add something on this one, or actually subtract 9, that's not a like term. So you have to be careful. You can't do anything with that term. All right, if you want to add and they don't look alike, right? So you have something like this. The radicals are not the same, what's underneath them, so you can't add 6 plus, that's like a 1 out front, because the 20 and the 125 are not the same. So the first thing you want to do is try to see if you can simplify these radicals. So I think that would be 25 times 5. And now from here, I can see I get 6 square roots of 4 square roots of 5, and plus square roots of 25 square roots of 5. This gives me 6 times 2 square roots of 5 plus 5 square roots of 5, which is 12 square roots of 5 plus 5 square roots of 5. Aha! They're the same now. So now I can actually add these and get 17 square roots of 5. So sometimes you can do some simplification so you can add them. If you're multiplying, say the square root of 10 times the square root of 5, remember you can bring both of those inside and get the square root of 50. From here, I could probably break that down into 25 times 2 and get 5 square roots of 2. You may have recognized, oh, this was 5 and 2. So you could have started out with what? The square root of 5, square root of 2, bring that one down and maybe recognized right away. So sometimes you can do these a little bit quicker. Let's see what else we got. So if I have something like 9 square roots of x quantity squared, what this means is 9 square roots of x times 9 square roots of x. I think 9 times 9 is 81. The square root of x times the square root of x is just simply x. You can distribute as well. So say I have the square root of 15 times the square root of 3 plus the square root of 5. So we know how to distribute. I'm going to multiply that, and then that gives me the square root of 45 plus the square root of 75. I know that 45 is 9 times 5. I know 75 because I think of quarters as 25 times 3. So this gives me 3 square roots of 5 plus 5 square roots of 3. Isn't that cute? They're like opposites, right? But they're not the same under the root, so you can't do anything with it. A big thing that we like to do with radicals is called rationalize the denominator. And all this means is we do not, when we have a fraction, we do not want to keep a radical in the denominator for many reasons that will come later. So if I have something like the square root of 2 over the square root of 5, remember you can do anything with this fraction if you multiply it by 1, right? Well, you're like, well, what good did that do? Well, couldn't I write 1 as the square root of 5 over the square root of 5? Why would I do that? Because that would get what's in this denominator. It wouldn't be under a root anymore. And so sometimes these are like really important, to get rid of that radical in the denominator. And they both don't have to be radicals. You could have something like 4 square roots of 7. I would multiply that by the square root of 7 over the square root of 7. 4 square roots of 7 over 7.